We're going to start the debrief session in about 30 seconds. I'd like to invite all of the technical leads or any note taker to come forward for any of the sessions and basically share some of your learnings. So we've had 4 different sessions, two parallel sessions. I guess we can start with the DevNet specs. Is there anyone from that session who would like to give us a quick summary?
So I'll do the first part, and then Raul will actually summarize the networking part. So we basically discuss about like the priorities that we want to achieve for these 3 days. Yeah, and so what we discussed is that for day 1 we just started talking about the P2P networking and the different designs and how do we incorporate that, whether it's going to be in DevNet 1 or 2, and it looks like we decided that we are going to be pushing some networking changes into DevNet 1 as well, hopefully, but that's still to be confirmed, but that's what we are aiming for. For tomorrow, we're going to be focusing mostly on the 3-client interop. So one way or another, we'll try to achieve proper like interop between the 3 clients, leanVM, and clean tomorrow. Also, start implementing the spec tests to confirm that all of the clients are working together. And then on the 3rd day, we'll be discussing about the DevNet specs. So all the details regarding the pq1-16 that we did for DevNet 1. And some discussion about signature aggregation. I think the recursive aggregation is likely not ready anytime soon, but we discussed about whether we can just do like no recursion. So basically just single signatures to multi-signatures, and then maybe concatenate those aggregations as part of some maybe DevNet 2. So that's the specking part that we discussed about, and then maybe go.
Yeah, so for the peer-to-peer part, we went over different designs and specifically how Lean would integrate with everything, with the networking stack evolution that's also happening in the L1. We just set up the team at the EF that's driving a lot of that roadmap. We're thinking of 2 different stages. There is kind of like from libby2b going into a more minimal. This is like very early, so please kind of like for now, keep it in this room. I want to make an announcement, like a broader announcement about the direction here, but basically going into kind of like a minimal distilled version of libby2b that consolidates the transport, that redesigns some of the machinery inside libby2b to make it more mechanically efficient in general with the protocol, and then expanding from that into a more specialized Ethereum specialized networking stack that instead of using a single gossip sub or gossip implementation for all different object types which have widely different characteristics in terms of sizes, dissemination, patterns, and so on, actually reasons about each of the objects as a distinct broadcast requirement. So basically building more dedicated protocols on top of like a more mechanically efficient stack. So kind of like that was the one big part of that. We went over many ideas around things like, for example, are browsers and mobile devices and constrained devices first-class citizens of the network or not? Do they interact through an edge layer? We went as well, we went over, is every node that wants to join the network, should it be a fully fledged participant of the network or not? Or is there like some form of proof that we can make that a node, like for example, prove a validator, that a node is effectively a validator to build kind of like a high performance like propagation layer between all these stakeholders in the network, things like that. We eventually decided that for DevNet 1, we're going to be iterating on the gossip layer to build and simulate propagation of aggregates through erasure-coded broadcast instead of gossip sub. And this later would be like that would be initially for global aggregates. Then we percolate it down to subnet aggregates, and all throughout we need to figure out how we're going to do like the initial signature dispatch, which is like the most intensive part of the protocol, and that requires more research. those are some high level notes.
Love it. It sounds like you've had all of these ideas kind of in the back of your mind for improvements to peer-to-peer networking, and this is like the perfect playground and testbed for these ideas.
Exactly, yeah, and I think the lean theme in general, that's something that we've been wanting to explore for a while, because what we have right now is kind of like a general purpose networking layer that, like, and the way that we use it is very bandwidth inefficient.
Right.
So as we push the boundaries, it's a good opportunity to re-engineer things.
Yeah, that's fantastic. And going back to your point that we don't have recursion yet, I guess I'm curious to hear, like, from Emil, like, when do you think we would have recursion, and is that something for DevNet 1, DevNet 2? Tonight. So maybe DevNet 1 is actually reasonable to have recursion. Great. Anyone else from these sessions who want to bring up a learning that they got, key insight? If not, we can move to the more theory sessions. Okay. Thank you so much, Owen. Thank you so much. Okay, next up, we have the theory sessions. Benedict?
Yeah, so we had a session on the proximity price, which I think was very useful for all of us to sort of see what the questions are that we need to answer. So what are the rules of the price? When do we award results? And how do we even decide which results to evaluate? And I think we made some progress there with respect to, for example, how to do some sort of spam protection for the judges so that they are not like spending 24/7 to evaluate things. So for example, limit the amount of submissions per submitter, or have sort of a ranking among the submissions, depending on what kind of criteria they satisfy. They will be evaluated sooner or later, or have sort of keep track of a list of known to be flawed proof approaches that sort of show up over time. And we made some progress with respect to how to present it and advertise it to communities. For example, an article in the AMS, Giacomo suggested some press tours and workshops, and rump session at Stock and Fox. Then also doing like numerical experiments and presenting them in the Journal of Experimental Mathematics. And I guess while the goal was stated to be reach agreement on the rules, I think this was a overly ambitious goal, and I think it's nice that we now sort of have even more questions about what the rules should be. I think that was also quite useful, and we will have the continuation of this session in the proximity jam session. So, Giacomo, is there anything you want to add?
Well, no, I think we have a lot of work to do. We need to get a move on and start writing things down. Like, I think, there's a lot of question on the theory side, but there's also a question on like let's call it administrative way. So yeah, like if we want to like, I think the price is already garnering some attention. I think we just need to make sure that we get something, good enough for when we decide to like properly announce the rules. So I think we just have to get a move on.
Yeah. Does anyone else want to add something?
Okay, so we can move to the final session, which got highly technical and lots of parallel discussions. So I guess, Giacomo, do you want to kind of, or anyone else who has some learnings about this very dense session?
You couldn't use Word with any linear code.
You can use Word with any linear code. That's a great property, an unexpected one that you can't explain.
Yeah, no, it's weird. I don't know.
There was one optimization around using base fields for the eval queue.
Yes, exactly. Like we by changing a few things, like we think that we can do a lot more of the first round in the base field, which should give us like some good optimization over there. There's some optimizations with respect to how to batch the in-domain samples, and there's some optimization about like figuring out how much we can shift from the polynomial IOP into the PCS. So I think,
I don't want to open up does this mean that your multilinear is over a small field to begin with?
My multilinear, yes.
Why not just use ring switching?
That's the other way we can do it. Yeah.
Then you have a fully black box invocation of war over the big field, and you don't have to.
Don't worry about it.
Yeah.
Absolutely. This is something else that we can do. Actually something that I think we should at some point figure out. To me, I never implemented ring switching. I don't have any feeling. I know you guys have considered it, and I wanna figure out a bit more of that.
As far as I know, ring switching requires extension degree, which is a power of 2.
Yes.
But it works. The issue is that if you want 128 bits of security, well, even with the up to capacity conjecture, you need a degree 5 extension of Qualabert.
Yeah.
We can. That's a pain in the ass.
Yeah.
Big 5 power 2.
I feel like that it's a shame that such a kind of seemingly technical obstacle would disqualify.
I think you could.
I think you could maybe get around it somehow.
For Goldilocks.
What, with degree 2 or degree 4?
Degree 4.
Yeah, but then you're paying, you would presumably do degree 3.
Guys, other question with ring switching, if
we do need ZK and have ZK as a requirement, do we have techniques to get ring switching and zero knowledge?
Yes.
I mean, using this sort of black box
Yeah.
IOP recursion
Okay.
stuff.
You
yeah.
don't leak the sizes of the actual things you're dealing with?
The sizes.
With your ring switching, don't you have like you're packing very small witness information into like larger field
Yeah,
elements, right?
that's right.
Is that leaking to the verifier the sizes of the witnesses?
The
it's
coefficient field it's defined over should be known to the verifier to begin with, right?
Correct.
So
I don't think that should be a problem.
Cool.
In other words, yeah.
This should probably be a side discussion.
Yeah.
Any other learnings? I mean, one learning that I got was that I think Angus believes that the DFT is like highly suboptimal, maybe in Plunky 3, and we have this way of potentially measuring the efficiency, which is like look at the number of multiplications that you need, and then measure that, and then take it relative to the actual running time. Yeah, better parallelization.
Yeah, I think this technique of computing the arithmetic intensity of the program that you're dealing with is in high performance computing is a very well used thing. If you go
the roofline model.
exactly this is how they, for example, Google publishes the performances of their GPU models for their GPU processors. So it's very good. If you understand what is the theoretical maximum of the system that you're working with and the resource utilization, then you can really do a lot of cool stuff.
Yeah, maybe we should add that to the a lower bound best implementation of where possible.
Yeah. For example, I don't even know if anybody did roofline models for field multiplications and field field operations.
It doesn't really matter for communication, it's more for FFT, but it's at log n.
Yeah.
Because you have n log n operation for n data, so your roofline model is log n.
There will be more bandwidth. Yeah, there's also things to try with cache oblivious FFT algorithm. There's a lot of things to try with that. But
yeah, so on FFT you have either you can express it as recursion, and in that case you can, if you do depth first iteration, the things that stay hot in cache, but I think lots of libraries are using the iteration things to remove the function called cost. I guess it needs to be benchmarked, and also the bit reversal permutation can be optimized maybe away as well, depending on how you arrange things.
yeah, in one of the original Word implementation, we also had the square root FFT approach, which according to Renko, I have no idea how these things work. It's quite good for the cache obliviousness part. So that turned out to be, I think it's quite nice. I don't know how it compares with the Plunky free approach. So it's all, the FFT, there's a lot of tricks. if they want to play.
Probably another side discussion. I mean, one of the meta learnings for me is that a lot of people that I thought were kind of very deep in Were and kind of experts were asking a lot of questions, and so I feel like very few people understand the guts and all of the implementation details, and there's possibly a lot of juice to squeeze from the fact that we're all just learning on the fly right now.
So I think everyone missed some optimization that were coming from lattice-based cryptography. There is this, I think so far everyone is using Montgomery representation for everything, but there is something called plantar arithmetic that was released in 2022 and improved in 2024 is about 20% faster for field multiplication on small fields.
How does it look like?
I can send you, I can put my research in the Telegram channel so that people can have a look.
Are other operations the same? Like is addition the same?
Addition is the same speed, but it's field multiplication that's much faster.
I'm curious if Angus, Thomas, Nico,
I'm not
Ben
heard of this.
have learnings.
I haven't heard of this.
No, not this specifically, but just general learnings.
I mean, I have something I want to push, which is often in this protocol, the multilinear pointers are helpful for us to understand it and to write it out, but our implementations don't need to think about them, right? And yeah, we can just deal with raw data and just reshape it and deal with matrix vector products. And I plug the Ligerita implementation as maybe an example of how to think about these things.
Oh, and please serialize them properly. Like this is something like been learned over the summer. Nobody serialized.
Zip your proofs.
Yeah, all proofs.
You get that very easily if you use a transcript API instead of structs.
Well, it depends, because you also need to have a Merkle tree API which supports capping and pruning, for example. So you know, and this tends to be a pain for recursion, but not in native. And there's a lot of these few things that yeah, you know, if you need to squeeze bandwidth,
Yeah.
like I think we have seen like the Word tree implementation is like 20% redundant, something like that.
Yeah.
So you know, if we need that extra bit of bandwidth, we can also do that. Which maybe, yeah, I don't know if it was a learning from the session, but I just want to point it out because yeah.
Okay, perfect. So this concludes our first day. Thank you so much, everyone. So we'll meet in 15 minutes. So that's at 5:35 at the Porter's Lodge, just next to the big chimney, which is the big entrance, and then we'll all walk together to go to Ponte, to the restaurant.